Gavin Gu here from UltimateReloader.com. I'm here at the 2020 SHOT Show with Emil Prasluk. Emil, you work with Lapua, Berger, Vidovuri, SK. There's kind of a lot of stuff here going on.
Right, that's all the commercial ammunition from NAMO here in the United States, and we're Capstone Precision Group, and those are all of our brands here.
And last year, right at the same booth, we had a really great discussion about wind, because one of your specialties is reading the wind and teaching other people to read the wind. This year, I thought it'd be interesting to talk about ELR.
Okay.
And I'll admit, part of my motivation is here is I want to pick your brain because I want to experience ELR this coming year. And I thought it'd be useful for my audience, for us to talk about kind of what is ELR and what is it not. How are some of the challenges unique compared to shooting out to, say, 1,000 yards? And then maybe kind of how you need to gear up for it. What kind of rifle you're going to look for, what kind of cartridge and caliber, maybe some of the other tools and accessories that are, and even the software, right? The apps and the ballistic solvers that are a part of being successful. So walk us through from the very start.
Sure. You know, there's lots of different definitions, and I think lots of different groups of people have different ideas and definitions about what ELR is. I think a good general description is anything past 1,000 yards.
Okay.
In practice, in extreme long-range matches, usually the first target is about 1,500 yards. So realistically, it's probably about 1,500 yards and beyond, but for lots of people with rifles that with common calibers that they're using in precision shooting or hobby shooting out to 1,000, I would say effectively using that system in an ELR context is probably greater than 1,000 yards.
Gotcha.
Yeah, and some of the special considerations are obviously the farther out you go, the effects of the wind are much greater. You know, as we know, as we talked last year, wind is what we call a non-deterministic variable. So, and non-deterministic, I had to look it up, means in the engineering context to not occur with certitude.
Tricky is another word for it, right? It is tricky. You
It-
can't put a
right.
number on it easily, yeah.
And then challenges are, well, just spotting your shots, physically seeing your bullets. If you don't hit the target, physically seeing the bullets. Another challenge is predicting your trajectory. The accuracy of your inputs. You know, these ballistic solvers we have now are very advanced. There's a few out there that are really high quality. Lots of engineering, lots of coding, lots of programming, but garbage in, garbage out, like any sort of computer system, right? So the accuracy of your inputs are really important. As a matter of fact, in the extreme long range matches that I compete in with the Applied Ballistics team with Brian Litz and those guys, they'll put multiple these they call it dongles, which is a Bluetooth device that's measuring temperature, the station pressure,
Wow.
humidity, and so that they can pull that stuff in from real time into the solvers, because
Wow.
a change from the morning shoot to the afternoon, 15, 20 degree change, and if the air density changes and all kinds of stuff associated, it could make you miss your target at these ranges of 3,000 yards, 3,500 yards, which is insane. The bullet's in the air for 9 seconds. So,
Wow.
yeah. And then some of the other things that are different on the rifles. So, obviously, the main challenge for shooting extreme long range sometimes is physically being able to have enough elevation on your rifle to hit the target. So most scopes, you know, the really high quality scopes, you know, I use a Nightforce ATAC-R, but even those scopes, they have roughly about 100 minutes of angle of travel, or you know, or about 27, 28 mils of travel. And if you're shooting a cartridge like a 6.5 Creedmoor, once you get pushing out to say 1,500 yards, you may be approaching the point where you can no longer have enough elevation in your scope, depending upon, so you have to get creative. Some guys have extremely aggressive rails on their actions.
Yeah, yep.
To add elevation. In ELR, where they're shooting past 2,000 yards easily. They're using these periscopes.
Yeah.
So
In fact, Night Force just introduced one, if I'm not mistaken.
they did. The one that you see most is the Charlie Tarek, which is a TACOM HQ, and that's a periscope version. So essentially, they set these periscopes up. It can either be mounted in line with your scope or be attached to the front of your scope, and it'll add 30 mils, 60 mils, 100 mils of elevation. So you just put this thing on and you can have your 100-yard zero on your rifle, and you put it on and you might have 30 mils of elevation on the gun. So because it can be challenging using ballistic reticles for ELR.
Sure.
So, a lot of us use ballistic reticles. We use, Mill reticles, Horus Tremor 3, H59. We use those reticles a lot. Problem is that another thing with ELR shooting is the targets are just small. They're really far away, right? So you have to use a good amount of magnification for these scopes. So if you take any scope and you crank it up to its highest magnification, 25 power, 35 power, 30 power, and it's a first focal plane scope, as that reticle gets bigger in size, it starts cutting off the mils on the bottom.
Sure.
So at max magnification, you may only be able to hold 10 or 12 mils of elevation in your scope.
Yeah.
So you're going to have to dial. So it really cuts down on your usable scope reticle, because the targets are typically pretty small. The standard size for ELR targets is 1 minute of angle at distance, or a straight 36-inch target at every distance. That's kind of the two ways that the targetry is kind of structured in different ELR matches.
Wow.
So a 36-inch target at 3,000 yards is pretty small. It's pretty small, right? So, and you have to dial your power all the way up. So that's a consideration. So you have to have a really good optic. You have to have the ability to have a lot of travel in elevation to hit it. The rifle needs to be optimized. All these things, most guys aren't using traditional fold-up Atlas-type bipods. They're using a much more rigid bipod system, because any pressures that you may not see at short range, you're going to see at those distances. And ammunition is probably the number one thing at those ranges. The velocity standard deviations and velocity extreme spreads, in order just to be able to hit a target at 2 miles using a caliber like 375 Chi-Tac or 416 Barrett, those are common calibers. Common calibers for extreme long range are 416 Barrett, 375 Chi-Tac, the 375 Enabler, that's the applied ballistics cartridge, David Tubbs caliber, 37 XC, and then people have necked down those calibers to 33 caliber, 338. So you're talking about shooting a 300 grain Berger hybrid at 3,200 feet per second. And so like the 375 calibers, you're shooting 400 size grain projectiles. Like we have Berger 407 solid bullet that we have.
Are those lathe turned?
They are. They're a solid monolithic bullet.
Good plinking ammo.
Yeah, with a 0.9 something G1 BC.
Wow.
And so a 375, one of those family of cartridges will shoot at about 2,850 feet per second. And then if you go up to 416 Barrett, you're shooting 550 grain bullets in excess of 3,000 feet per second.
That's
like more like 3,100 feet per second. Oh yeah.
And you were talking about SDs and ES numbers and what it takes to get on that target at that distance?
Yeah, so at those extreme ranges, the difference in 1 or 2 kernels of that powder may take you off the target for velocity.
Wow, and usually, so if you're doing your chrono validation of your ammo, what are you looking for an SD that's realistic?
It's got to be 7 feet per second or better.
Okay, yeah.
100%.
Yep.
Most of those guys are trying to get down into 4s and 5s.
Yep. So it's good because I have Adam McDonald's auto trickler system. I have an A&D FX120i scale, so now I can read at 200ths of a grain.
Yep.
Which is about 1 granule of certain types of powder.
Right, and that powder, it gets kind of big. The 2 main powders that are used in ELR for those large calibers are Vitavori powders, 20N29 and 24N21. Those are the powders. And so they're fairly large kernels. They're made for 375 to sort of 50 caliber size cartridge cases.
Slow burning and
Yeah,
just,
I mean, like for a 416, you're burning close to 200 grains of powder per shot.
yeah, that's a lot. And do you have to cut kernels at all? Cut sticks?
No, guys don't do that.
Okay.
I mean, you're within a kernel.
Okay.
And a kernel is about, 0.04 or so of a grain. So yeah, I mean within a kernel is okay, but you really need a system like equipment like you have, or just painstakingly slow like old school way. But
how important is it to find that velocity node for stable? Because you're talking about differing environmental conditions. Ammo is going to change temperature.
Yeah.
The atmospherics are going to change. If you're on a node, you have a little bit more wiggle room, right? Where there's a stable burn going on and that kind of thing. Do you look at that?
There's two schools of thought.
Okay.
Some guys just want to burn it down. They want to shoot it as fast as they can
Yep.
to get that extra velocity. My thinking on it is, after doing it for a while, and all my years of experience in shooting, long range shooting, is velocity does not necessarily win you anything ever. It's always precision. So two things. Almost all these calibers, except for some of the 416s and shooting in extremely thin air. So at Raton, the firing line is about 6,600 feet above sea level. Right. So that's a very extreme terrain and geographical conditions, so that it extends the supersonic range because of the lower air density. Right. So if with the 416 and like a 550 grain bullet, it's probably still supersonic at 2 miles.
Wow.
But if you're shooting that match in Camp Atterbury, Indiana,
Yep.
or somewhere in Ohio, or somewhere in Georgia, close to sea level, almost all of these projectiles, no matter where the caliber, are subsonic by the time they get to 2 miles.
Wow.
Or 3 miles. First it was the king of 2 miles, now they're shooting 3 miles, now they're shooting 4,000 meter matches.
Right.
Right, so close to 4 miles. So if you make the assumption that your bullet is going to be subsonic no matter what,
Okay. Yep.
it makes no sense to try to shoot as fast as you can.
Yep.
Even if you have to back it down 20, 30, 40, 50 feet per second to get those extreme spreads down, and to make sure that you have no pressure problems unintended
Sure.
on match days. We all know you develop a load at your home station, you go to a match somewhere else, and it's on the edge of pressure,
Yep.
and one environmental condition, whether it's temperature or whatever, makes that a little bit overpressure, and you have poor results.
I had that problem at a PRS match with 22 Nosler. Good load, 95-degree day, I'm out in the sun, all sorts of functioning problems. Yeah, so
Some guys don't learn. I mean, you still see guys at ELR matches that go up to the line, they have their ammo, they have the rifle, put the bipod down, and then they put like a little hammer next to their ammo to knock the bolt open. And I try to stay away from guys like that.
So my school of thought is there's the internal ballistics.
Yep.
We're looking for that stable node where you can vary the powder charge a little bit and not have a whole lot of velocity variation. And then there's the rifle dynamics.
Right.
When the barrel is whipping around due to the resonance and those waves that are going down the barrel and all that, you want to find the spot where the barrel, when the bullet is exiting the barrel, it's either at the top or the bottom, and not in the middle where the whip is at its maximum speed. Those sorts of dynamics.
Sure.
That nobody fully understands.
And nobody, and you'll get differing opinions on
Yep.
whether barrel vibration and nodes are even a real effect. It's something that we've always talked about, but I've sat through briefings and guys that are in some of these programs where they fully instrument these barrels. They take high-speed cameras of these barrels, and sometimes the bullet is completely out of the barrel before you see any movement. So there's still a lot of research to be. I mean, as we know, vibrations travel through steel faster than the bullet does. There have to be effects, but how that actually works is very interesting and bears a lot further study. There's even a theory
Okay.
that the nature of group size has more to do to where your barrel comes to rest after each shot, rather than what happens during the shot.
Gotcha.
So from shot to shot, the vibrations and everything will the barrel will end up in a different spot,
Right.
which is
Right.
mind-blowing if you think about it.
Sure. Yeah.
But all the things that we do, bedding actions, stiff actions, having high, thick profile barrels,
Barrel rigidity.
barrel
Yep.
rigidity, that's probably still help, even if it is that is the case,
Sure.
that still helps that. And that's not my personal theory, but that's what it's actually
Yep.
from some pretty advanced people within like the military
Yep.
ballistics
Yep.
guys. They think that.
Well,
so it
and
is
what,
interesting.
What you can look at is the results.
Yes.
And what I'm looking at is two things. I'm looking at my ES and my SD, because for longer range, obviously, that's a real consideration for vertical dispersion. And then I'm looking at my group size. And if you find that load where you get good precision and you get stable velocity, for me, when I'm shooting like at 1,000 yards, for instance, that's the magic combination that I'm looking at. Is that kind of your general thought process?
Yeah, exactly.
Okay.
Yeah, exactly.
Very interesting.
And then you have to know where the bullet's going to hit. So solvers and ballistic coefficients, it is very interesting, the dynamic there. I think that consistency of ballistic coefficient is much more important than a high ballistic coefficient, especially at those ranges. So, we have a radar, as other people do in industry now. They've kind of proliferated. They're not cheap. It's definitely not something that the home reloader is going to want or afford.
Sure.
But
This is like at Applied Ballistics and looking at the Doppler down the range. and that
exactly,
kind of stuff.
a Doppler radar system.
Yeah.
Regardless of the system, you're probably knocking on the door of six figures for something like this. But now that we have these things, you can see the bullet in flight out to 1,500 yards beyond, and depending on the size of the projectile and other things. And what we're seeing now is how consistent BCs are from shot to shot. So, as we know, ballistic coefficient is it's a combination of the form factor of the bullet and the sectional density of the bullet. And then you can calculate what the ballistic coefficient is going to be at any range based on the velocity of that bullet.
Sure.
And we know that ballistic coefficients change with velocity. If you have a box of bullets and you see the number on that box of bullets, and the manufacturer is giving you a number at the muzzle or at Mach 2.2, 200 yards, and another manufacturer gives you a ballistic coefficient number that is an average ballistic coefficient over a range, those numbers are going to be different, even though they might have similar performance.
Sure. Yeah.
So, but from shot to shot, those ballistic coefficients can change. And so really good bullets are 1% or less. And that's what you need that over that range. And you also need your bullet to be stable through transonic. Some bullets are great until they hit about Mach 1.2, 1.3, and then all of that sort of instability happens because the bullet is really being roughly treated as it goes through that transonic zone. So if the bullet isn't extremely well balanced, if you don't have the right rate of spin on that bullet, it becomes unpredictable past it. So the biggest challenge in ELR is you make a prediction, you make a win call, and at first shot, if you happen to hit the target, great. Typically, guys don't.
Right.
Which is, you see things about a first-time shot at 5,000 yards, 6,000 yards. Always be very skeptical of those claims because, we're talking the best guns, the best guys, purpose-built rifles, $10,000, $15,000 rifle systems, hand-loaded ammo, lathe-turned bullets, and guys are hopeful that they're within a target or two, up, down, left, or right.
Gotcha.
And then from there, you can bring it onto the target.
So in the King of 2 Mile, for instance, that would be a typical scenario that would unfold where you're a couple targets to the left or something like that. And
for me personally, when I'm doing the wind coaching for that, I expect us to hit the target the first shot probably out to about 2,400 yards.
Wow.
After that, or be within a target.
And that's about a 1 MOA target, did you say?
Yes.
Yeah, okay.
Yeah. And then after that, just light, how the target may appear, could shift the image a little bit. That's another thing we don't really understand a lot about, how light affects where the target is. So you might have a perfect solution, but the target just looks like it's in a different
You're
spot.
aiming in the wrong spot.
Yeah. That happens. So another issue at those ranges is something that I've really dug deep on is wind gradient. So that is the difference in wind speed from ground level to up high where your bullet is. So like on the 375 like Enabler, the applied ballistics cartridge that we shot last year,
Yep.
at 2,500 meters, the maximum ordnance is about 80 meters in the air.
Wow.
So that, depending upon the nature of the terrain, the wind can be only about 10% higher if it's nice and smooth like a lot of rifle ranges, or if it's really rough and broken terrain, ridge lines shooting across a couple of different terrain features, rocks, cactus, all that crap, the wind could be 300% greater at max ord.
There's nothing blocking the flow once it gets above those
Right,
layers
because
of terrain.
wind acts like a fluid, so surface friction slows it down, and the higher you get off the ground, the surface friction becomes less, and the wind speed will then pick up.
Yep, just like in a river, the top of the river is flowing fast, and the very bottom is
Exactly,
practically
and
still.
these effects, if anybody really wants to study this stuff, you can start on like Wikipedia, look at things like, it's called wind shear. Then there's actually some formulas to calculate wind at different heights, and these formulas all have an exponent, which is a coefficient, which corresponds to the nature of the terrain. So these are calculations you can't really do in your head while you're shooting.
Yeah.
But I think they might be useful if somebody wants to include them in a ballistic solver, or it might give you some sort of general understandings. You can kind of, that's what I do. I use it to simulate and do some modeling
Nice.
based on what I think the range is going to be, so I can make some assumptions. So if I'm measuring the wind at like 6 feet, holding up my Kestrel, and I know that we're shooting at like 1,500 yards, and my max ord of my bullet is about 20 feet in the air, I might add 10% to my wind call. Because I am assuming that the wind is greater for the middle third of that trajectory. And knowing where the wind matters is another thing. So
we talked about that a little bit.
we did. We
last
talked
year.
a little bit
Yeah.
last year, but the farther you go out, that last third becomes more and more and more important. And since you can't instrument it down there, you have to really get and look. So to the point where some guys, if like in King of 2 Mile, the targets are hung on these like cliff faces, and at the far targets, instead of going for the target, the first shot, because maybe the target has dead space to the right or to the left, or if you go over it, you're not going to see it.
Sure.
If you go right or left, you're not going to see it because it lands maybe behind sloping terrain. A lot of guys will shoot their first shot low, just burn a miss, even though they only have 3 shots. They'll burn a miss to hit the rock and see the wind and see whether see how high or below
Wow.
their elevation is.
Wow.
And spotting can be challenging because at those ranges, you can't just say, come a little left, come a little right. So you can use target, hey, come 2 targets left, come 2 targets right, hold top right of the target, hold bottom left of the target, or some scopes now have a reticle in the spotting scope.
Oh,
So
yeah.
Vortex has one, Swarovski has one that's an LED, you can turn it on and off. There's a Leupold. If you really want to pay, as my father used to say, folding money, you could have one of these Hensoldt sniper spotter scopes, like Spotter 60, but they're talking $4,000 or $5,000 for a scope.
Sure.
And they have a reticle in it. So that reticle helps the shooter, so helps you talk the shooter onto the target.
Yeah, yeah.
Tell him, it's like you see the splash as a spotter, and I'm wargaming. Another thing that I do at those ranges is just an extension of how I do wind reading normally. I'll have a little sketch for each target, and I'll have how wide that target is in miles per hour.
Nice.
So I'll calculate target size. I know how much the bullet drifts in mils or minutes, depending on what scope the guy's using. And so if I know this, say the target is 0.7 mils wide, and my drift at that range is 0.1 mil per mile an hour, I know that target is 7 miles per hour wide.
Yep.
So if it's 3.5 mile an hour wind, I tell them to hold on the upwind edge to hit center, or I know what I can get away with to hit left or hit right. So that's very important if you're spotting at those ranges, of knowing the target size, number one, so that you can talk the guy on. If
Yeah.
you could tell him, hey, you need to hold 0.5 left and 0.7 or 0.8 high. You can use that target as a reticle if you don't have a reticle in your
Yeah.
scope.
And that's where your team has to be in sync, right?
You really do.
Practice together, you know how to communicate. All of this in the head math and solver stuff is muscle memory.
And having some SOPs about what we do, contingency plans. X happens, we do Y.
Right.
Here, a perfect example of is that at those ranges, even the best rifle and the best ammunition, your group size is more than likely going to be bigger than the target. 100%. If you have a
Wow.
if you have a legitimate, 1 minute of angle gun, everything included, at 2 miles, your group size is what, 35 inches or so. And you're shooting at a 36-inch target. If you're on the outside edge of your group size, if you miss just right, you might not want to hold left edge.
Interesting.
You might want to shoot center again.
You have to think about that dispersion, that shot dispersion, and read that.
And we should always do that.
Yeah.
No matter what range guys are shooting. You're shooting on steel at 500, 600, 700 yards. You should always think about group size and try not to chase it.
Yeah.
Because you might be on the outside radius of your group size. But in ELR, it's more important than anywhere else.
Wow.
So even if you miss completely, you probably have a higher hit percentage to just hold center again.
Wow.
And there's some software. There's like the Applied Ballistics has like a desktop version, the WEZ or Weapon Employment Zone, and it lets you model. And so it'll basically project group size and simulate 1,000 shots on the target.
Wow.
And you can put all kinds of different inputs in there, how precise the rifle is,
Yep.
and standard deviation, and yada yada. And you'll see that, like, if that's your group size, it can teach you to not do that. Another thing that you see is sometimes the guy shooting on the ground level through his scope, he can see his own impacts better than the guy behind him on his spotting scope.
Wow.
I don't know why. That just sometimes that's the case. So you're looking for the plume of dirt
Sure.
or some splash somewhere.
Yep.
And so if anybody sees it, that guy's in command.
Gotcha.
So if I'm back there with my spotting scope, with my beard and my little notebook and all of my devices,
Yeah.
and I can't see it, but the guy on the ground goes, "I got it." I'm like, "All right, man, go." Because so if he sees it right, he's going to hold left. Everybody just needs to tell everybody what they're using.
Sure.
And things like spindrift, actually, it's what some people call them earth-based effects. They do come into play. So Coriolis, spin, all those things you probably want to, and direction of fire, right? So, which is part of Coriolis. You want to probably include those into your system. And how guys manage that and mitigate that can be different too. Some guys want to dial it out. So it's neutral, so they can go left to right. Some guys want to dial on or hold the complete number, right? So there's things to be said for both ways of doing that. The complete number is fine, but if the conditions change, you have to keep in your head
Yeah.
what those other offsets are.
Yeah.
Dialing it so it's neutral is kind of easy. The problem with that is these are very fast-paced events, so they may give you 5 minutes to shoot like multiple targets at multiple ranges.
Yep.
So you're shooting, you might be shooting 9 to 12 shots in like 3 to 5 minutes. So transitioning from target to target, if you have things dialed, elevation and windage, you have to remember that that's on there.
Yeah.
If you go to
Yeah.
the next target, you have the wrong thing on there, you miss and you don't know why.
Yeah, that always knowing where your reference point is, whether it's absolute or relative. I was thinking about, do you dial for a mover target, right?
Right.
Or do you hold? And that's something that you have to train for, and multiple ways to get to the end.
Yeah, I
but-
mean, it depends on the scenario.
Yeah,
Right.
exactly.
I mean, I know that in the tactical type environment, some guys will dial if they're shooting movers, they may just dial 2 mils of elevation on the gun, so that like with a ballistic reticle, they don't have to try to hold down in that like Christmas tree
Sure,
area.
yeah.
They can hold the mover on the main stadia line.
Yep.
And then if it's a directional mover and it's going to be that direction, like if you're in a match, then maybe guys dial on
Yeah.
the lead.
Right.
I mean, back when running target was an Olympic event, which was a moving target, they shot with air rifle at 10 meters. they had scopes that were designed that the whole reticle, everything was offset with the lead built in for the speed. So you always held center. So if you know it's always going to be like
Yep.
that, you can do that.
Wow. Okay. Well, you've given me a lot to think about. As I mentioned, I'm interested in getting into the ELR
Yeah.
game, and I'm going to kind of incrementally work my way towards that goal. I might start with a 30 cal Magnum and go out beyond 1,000 on my property, and then look at what's going to be the right cartridge and what's going to be the right style of bullet and the prism, your periscope kinds of considerations. There's a lot really to think about.
I would say that, so putting my burger hat on, our new long-range hybrid target bullets were designed to all have less than 1% ballistic coefficient consistency. Like, for example, the 7mm 190 grain, we were filming a promo thing for it, and we were shooting it over radar, and it was 0.5% of BC variation. That's
Wow.
it. And that's almost unheard of. So, and those bullets are all very stable through transonic into the subsonic. So I would look at a hybrid type bullet.
Okay.
And again, remember, consistency is more important than BC at those extreme ranges.
Yeah. Awesome. Well, what do you guys think? I'd like to hear your feedback. Are you shooting ELR? Do you want to shoot ELR? Let's discuss. And Emil, thank you for talking with me once again.
My pleasure.
It's been totally eye-opening for me, and I'm really looking forward to pursuing some of these goals. And don't forget to subscribe with notifications, because I've got a lot more SHOT Show 2020 content coming up, and I got a lot more related content with long-range rifle shooting. It's good stuff.
And if they want to look at any of our products, they can go to capstonepg.com or the other websites, burgerbullets.com, Lapua, all the other web. But you can get all of our products from the capstonepg.com website.
And I'll have a link in the video description as well. Until next time, happy shooting and happy reloading.